Hi, today I'm going to present about MTES 3203, solving a non-routine problem using matrix representation. Next, we'll move to objective. There are three objectives. First, to model the real-world situation using algebraic equations and represent them in matrix form for a structured and efficient computation process. Second, to apply Poyer's four-step problem-solving method as a systematic guide for analyzing, planning, executing, and verifying the solution. Third, to analyze, interpret, and reflect on the mathematical findings to draw a meaningful connection between abstract reasoning and real life application. Why choose matrix representation? There are three reasons why matrix representation is chosen. First, conceptual and theoretical basis. Second, educational and cognitive benefits. And last, efficiency and systematic problem solving. Conceptual and theoretical basis. It represents Bruner's symbolic mode for modeling abstract relationships systematically, and it reaches iconic to symbolic reasoning, supporting deeper conceptual understanding. Educational and cognitive benefits. It enables learners to visualize patterns and dependency among variables, and promotes critical thinking and higher order reasoning in non-routine problem solving. Last, efficiency and systematic problem solving. Matrix representation via Gaussian elimination provides a clear, structured, and efficient method for solving simultaneous equations. It organizes data in rows and columns, reducing cognitive load and calculation error. Now, let us see the non-routine problem. A local art teacher is preparing for a mathematical sculpture exhibition and designed four miniature sculptures made of different materials. A bronze cube C, a marble sphere S, a glass cone N, and a clay pyramid P. Since each material has a different density and size, their weights are not the same. To pack them safely for transport, she uses a digital balance to compare their weights and record the following result. First, two cubes and one sphere balance one cone and two pyramids. That is 2c plus s equals to n plus 2p. One cube and three cones balance one sphere and two pyramids. That is c plus 3n equals to s plus 2p. Last, two pyramids and one sphere balance three cubes and one cone. That is 2p plus s equals to 3c plus n. After taking these measurements, she discovered that the marble sphere weighs exactly 6 grams. Based on this information, determine the weight of each sculpture before packaging. Poyer's problem-solving step using matrix representation via Gaussian elimination. There are four steps for Poyer's problem solving. Step 1. Understand the problem. We will identify the unknown C, S, and P and write balance comparison as equation. Step 2. Devise a plan. We will represent equation in matrix form. Choose Gaussian elimination to solve them. Step 3. Carry out the plan. We will perform row operations to simplify the matrix and use back substitution to find each value. Step 4. Look back. We will check the answers with original equations and explain what the result mean in real life. Let's see step 1. Understand the problem. Based on the non-routine problem, we can know that a local art teachers designed four different sculptures, a bronze cube, a marble sphere, a glass cone, and a clay pyramid. Each of them has different weights. The teacher has used a digital balance to compare their weights and record the following relationship, which are the three equations down here. We are also told that the S is equal to 6 grams. Then we need to find the weights of C, N, and P. Then the next one is step 2, devising a plan. To solve this non-routine problem, I use matrix representation because it provides a systematic and efficient method to handle multiple equations simultaneously. By expressing the system in matrix form, Gaussian elimination can be used to find the unknown weights. Before performing the matrix, I will first substitute s equals to 6 into the three equations to reduce the number of variables. Let us proceed to step 3. Carry out the plan. There are three equations up there. Then we need to substitute s equals to 6 into each equation. When we substitute the x equals to 6 into the 2c plus s and n equals to n plus 2p, we will get the first equation, which is 2c minus n minus 2p equals to negative 6. Then when we substitute x equals to 6 into the equation of c plus 3n equals to s plus 2p, we will get the second equation, which is c plus 3n minus 2p equals to 6. Then when we substitute s equals to 6 into the last equation, that is 2p plus s equals to 3c plus n, we will get the third equation as 3c plus n minus 2p equals to 6. Then we can base on the three equations just now to write it in matrix form. The first row, 2, negative 1, negative 2. Second row, 1, 3, negative 2. And third row, 3, 1, negative 2. C and P then is equal to row 1, negative 6, row 2, 6, and row 3, 6. Then we can also change it into the augmented matrix, which is row 1, 3, negative 1, negative 2, negative 6, row 2, 1, 3, negative 2, 6. Row 3, 3, 1, negative 2, 6. Then apply the Gaussian eliminations. We can start with the original augmented matrix. To make the top left pivots equals to 1, we can exchange row 1 to row 2. Then the matrix will become 1, 3, negative 2, 6, 2, negative 1, negative 2, negative 6, 3, 1, negative 2, 6. Then row 2 becomes row 2 minus 2 times row 1 to eliminate the value in row 2 under the first pivot. Then the answer for the row 1 will become 0, negative 7, 2, negative 18. Next, row 2 is multiplied by negative 1 over 7. To get the answers for row 2, 0, 1, negative 2 over 7, 18 over 7. Furthermore, row 3 becomes row 3 minus 3 times row 1. We will get the answer for row 3 becomes 0, negative 8, 4, negative 12. Proceed. The row 3 becomes row 3 plus 8 times row 2. To eliminate the second column entry in row 3. Then the row 2 becomes 0, 0, 12 over 7, 60 over 7. Last, row 3 is multiplied by 7 over 12 to get the answers in row 3 equals to 1, 0, 0, 1, 5. After all, we can base on the matrix to know that p equals to 5. Then substitute the p equals to 5 into the equations, which are c plus 3n minus 2p equals to 6 and n minus 2 over 7 p equals to 18 over 7 to find the value of c and n. First, we can substitute the value of p into the equation n minus 2 over 7p equals 18 over 7. We will get n minus 10 over 7 equals 18 over 7. Then answer or value for n is 4. Next, substitute the value of p equals to 5 and value of n equal to 4 into equation c plus 3n minus 2p equals to 6, c plus 3 times 4 minus 2 times 5 equals to 6, c plus 2 equals to 6, then the answer for the value of c is 4. Last but not least, step 4, look back. Verify the answer by substituting back into the original equations. 2c plus s equals n plus 2p. c plus 3n equals s plus 2p. 2p plus s equals 3c plus n. Then the answer is 14 equals to 14, 16 equals to 16, and the last 16 is equal to 16. Hence, the left-hand sides and the right-hand sides are equal in all the three equations. This verifies that the calculated values for C equals to 4 gram, N equal to 4 gram, P equals to 5 gram, and S equal to 6 gram satisfy the given system perfectly. The row chart clearly shows the weight distribution of the four sculptures. The marble sphere is the heaviest at 6 grams, followed by the clear pyramid at 5 grams, while both the bronze cube C and glass cone N weigh 4 grams each. This horizontal display allows an easy side-by-side comparison, highlighting the gradual increase from the lighter to the heavier sculptures. The pattern reflects real-life density, where marbles is naturally heavier and confirms the accuracy of the computed result. All in all, these non-routine problems show how matrix representation and Gaussian elimination can solve real-world mathematical situations effectively. By modeling the weight relationship among four sculptures, the process connected abstract equations with practical understanding. The use of the row charts made comparison clear and helped verify results. Overall, the investigations proved that matrix representation is a powerful and meaningful tool for organizing data, solving problems logically, and linking mathematics to real life contexts. And thank you for listening.